manufacturer of this osmometer is called Advanced Instrument, and the name of this osmometer is Osmo 1. So this advanced osmometer uses a freezing point to measure osmolality. Osmolality is the total solute concentration of an aqueous solution. Osmometers are used to test blood serum and urine in the laboratory. Osmometer is a unit of concentration that takes into account the dissociative effect, and osmolality is usually expressed in MOS m/kg H2O. So this is the osmometer. Let me show you the parts of the osmometer. So we start with the top here. So this is a chamber cleaners, and this chamber cleaners is actually attached to the osmometer. So there is an RFID at the bottom here. This RFID actually counts the number of chamber cleaners and sampler tips that are on top here, and every time we use one, the number reduces. So every time we open a chamber cleaner and sample tips, we have 500, and once the 500 finish, it will alert us and we have to change to a new one. Then we also have a plunger wire here, which I don't have it now because we have already put it into the sampler. So this is the sampler, and yeah, so in the middle there is a plunger. So this plunger is changed at every 500 tests. Okay, and then so this is a touch screen, and this is the cooling chamber. So here is where the freezing point will take place. This is the sampler holder. So later when we're running the test, the syringe plunger will go inside here, and this is a barcode reader. Yeah. So how do we run a sample? So this is a plunger, and this is the sampler tips. Take a sample, and then we put the sampler into the sample and take out some of the serum. So if you can see, the serum there will be 20 microliter of serum taken by the sampler. So to run this osmolality test, we just need 20 microliter of sample. So we also have to ensure that there is no excess of serum on the top, because if there's excess, then the results will not be accurate, or we will not get a result at all. Okay, so once we've taken the sample, we can remove this chamber cleaner, put the sampler into the cooling chamber, and we push this sampler holder. Okay. Type the sample ID, so I will just type the sample ID while this sample is running, you can see the progress of the test. So it's supposed to reach up to 100%. While it hasn't reached up to 100%, we can actually still change the sample ID if we have keyed in wrongly. Okay, so then it will ask us to remove the sampler from the clean chamber and clean the chamber. Okay. Remove the tip. Wipe off and clean this sampler. We use a tissue, and we have to make sure we really wipe off so there's no residues inside. And then we replace it with a sampler tip, and then we put it back. For maintenance for this, there are 3 types of maintenance. One is cleaning the air vents, so there's a fan behind here for accumulation of dust, but we can do it monthly because we are in an air conditioned area, so we might not get a lot of dust in the air vents. Cleaning of instrument exterior, so the exterior is this part, so if there's any blood stains, you have to use alcohol swab to wipe off, and this can be done weekly. And maintenance as needed, we have the dent changer cleaning. So for the normal, every time we run a sample, what we have to do is we have to put these chamber cleaners inside this chamber, and then turn to the right 5 times. Okay, and then we remove and turn to the other side, and then we turn to the left 5 times. For the dam chamber cleaning, which is as needed, the additional thing we have to do is we have to dip this chamber cleaner into 70% of isopropanol solution, and to do the same thing now, we have to turn and clean 5 times on the right, and then turn the other side and then clean 5 times on the right. So after we have done that, this chamber cleaners we can just put it here to avoid dust from entering the system. Okay. So as of now, we don't have any calibration for this osmometer. The calibration is done by the manufacturer themselves, but we do have calibration for this sampler, which we have to do every time we change the plunger. So this is the plunger, and then this is the needle calibrator. So what we have to do is we have to remove this. Okay, and we have to put it into this hole and spin anti-clockwise. Okay. When we spin anti-clockwise, we shouldn't be able to press this, but we should be able to pull out the plunger. Okay, and then after we replace a new plunger, we put this. So when we replace the new plunger, we have to put it in through this way. Okay, and push it back here. So this is the needle calibrator. So this needle calibrator is actually 20 microlead. So when you push it here, we will be able to get the 20 microlead that is required. Okay, then to put it back to normal, turn it clockwise. Okay, and then this one can put back here, and we should be able to press as per normal. As of now, this analyzer is pretty new, so there is not much troubleshooting that needs to be done. Most of the time, we have to call the engineer if needed. Thank you. Assignment.
Okay.
So this is a biosafety cabinet. It's a class 2 biosafety cabinet that we use in our microbiology lab. So as a maintenance, what we will do is we will switch on. Before we switch on, we will disinfect the area with 70% alcohol first, and then we will switch on the biosafety cabinet. Okay. As a maintenance, we have a checklist of the things that we need to check. Number one is this blower. So we need to ensure that this blower is on. So what this blower does is that it actually traps the air inside the biosafety cabinet to not allowing the air to come out and air from outside to go in. Up here we have a HEPA filter, and this HEPA filter will will recycle the air from inside here, filter in the HEPA filter, and then it will send back the air down on the biosafety cabinet. And for this window, we also have an alarm to ensure that the level is the appropriate level and a safe level for the staff to process sample. So before we start using, we have to leave the biosafety cabinet on for 15 minutes, and then only we can start processing the samples.
Stop.
This is a OPSE U411. It is used to run urine FEME samples. So OPSE U411 is a semi-automated urine analyzer that's supposed to run in vitro qualitative urinalysis samples. So the test that we have, for example, is urine pH, specific gravity, leukocytes, red blood cells, white blood cells, bilirubin, urobilirubin, protein. And the test kit that we use is Comber test kit. Right, so the principle of this analyzer is coloric method, so which means that it reads the changes of the color. So how this is done is, the test kit, we will pour urine on top. Okay, so we'll put the sample on this tray and it will automatically go into the analyzer. So here is where they will read the coloring method. We have a inside printer here where it will print the result. This is the monitor screen where we can key in the sample ID and also look for the results, previous results. So we also have a tray at the bottom here where we have to open to remove and discard all the, so that's part of the maintenance, which is discarding all the used strips. That's one of it. And other than that is more of surface maintenance, so we will clean the surface. For calibration, we have a calibration strip. This we do every month or when needed, or usually when the engineers come and do their own calibration and ppm, so then we will have to do calibration and run QC. So after it's done, then the results will be automatically printed and we key in the results according to the printed results. This is another analyzer. This is called OPSE Infinity, where we use this as our sorting machine, archive analyzer. It will centrifuge the sample and also carry it to the appropriate analyzer to run the tests. So far we have only been using it for biochemistry tests. So this input tray is to put in samples. So for example, we take one tray and then we put the tray here and close this ledger, and the sample will be carried in through this tray, and then the conveyor belt will bring it inside, where they will, if there is a sample, then they will carry the sample and put into the rack, and then the rack will be put into the centrifuge, which is at the bottom here. Okay, so right now what I'm going to do is I want to archive some samples. Okay, so this model is where we put in the samples. So actually we can put in samples to archive, or we also can put in manually spin sample. We put it here and then they will uncap and it will sort it to the appropriate analyzer to use. you can see the mechanical hand picking up the sample and slotting it into the LLD. So LLD is where they will measure the sample, and then it will go through the OS camera module. The camera module will actually take a picture of the sample, so we can look at the integrity of the sample, and after that they will scan the barcode to see what test needs to be done, whether the sample is complete and it just needs to be archived, or if there is no pending sample for the sample to run. Other than that, it also helps to detect error, so that's why they take picture. If there is error in volume, then it will be loaded into the error volume tray. If there is an error with spinning error, then it will be sorted into the error spin tray. Then we also have a tray for pending, and for the sample that needs to be run for ionized calcium. So this is how a archive sample looks like. There is an area where they will put a foil for the sample before it's being archived. So here is where the foil is, and this is the decapping area. As for troubleshooting, there is many forms of troubleshooting. Perhaps I will show one of it. Sometimes the centrifuge gets jam, or sample gets stuck in the centrifuge. We have to manually open the centrifuge. Unscrew this screw, wood screw, and then pull out the centrifuge and open it. I can't do it now because there is a sample inside. So we also have this thing here. If the centrifuge is faulty, we use this, put it inside here to stop the centrifuge. Other than that, sometimes we will have the foil error, where there is insufficient foil, or the foil is being placed in a different direction. Then it will give us error. Then we will just have to change the type of foil. We also have this control unit screen to tell us and show us what's happening. As for this input trays, here is where, if there is a sample to run, it will come to this rack, and then this rack will be carried using the conveyor belt into the analyzer. Good morning, startup. So this is our Cobas 8000. So we have 3 modules in this Cobas 8000. We have 4 actually. So there is the ISE model. This is the ISE model. Then we have C702. We have C502. So C502 and C702 are the chemistry analyzer, where it will run all the chemistry tests. And then so basically it's the same, it's just that there is a difference in the type of reagent used. Okay, and then we have E801. E801 is where we run all our immuno sample. So okay, so we will start with the C702 and C502. Both use spectral photometry as the principle. We have about 32 types of tests that we run here. For example, ALT, AST, urea, and uric acid, like renal profile test, LFT. All we will use the C702 and C502. And for example, for immunology sample, it's like TFT, thyroid function test, cancer markers, and all. So here, let me see if we have a reagent. So the difference with this is that the reagent cassette is different. I will show you later because it's not here. So we have a list of maintenance that needs to be done, which is here. So I just started this machine, so I have to do maintenance. So we go to utility, and then we go to morning startup. Okay, so we have to click morning startup and press select and execute. So when we do morning startup, what it will do is that it will do maintenance for the entire machine, where it will rinse all the probes, the reagents, all will prime so that it's ready for us to use. So while the piping is going on, I will go and unload the QC so that we can run the QC after the maintenance is done. Here I'm actually allocating the QC that I took out earlier to run in the OPSE analyzer.